Okay. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet. We are having this scenario now. It says a pump is needed to lift water through a vertical distance of 25 meters at a steady rate of 180 kilograms per minute. So this is the scenario. This is the pump. So the motor is pumping water. The water is going through the vertical height. So we're having the question now. It says calculate the minimum power of the motor that operates the pump if the velocity of the water is negligible at both intake and outtake. So how do we get this power? So you have to know something if you're going to approach this question. We say power is equal to work over time. Now, when you look at this scenario, we have to remember that work and energy are brothers and sisters. So the motor is doing is expending gravitational potential energy lifting the water. So in other words, we are in position to say that work done in this case is equal to change in potential energy. So it's going to be a change in potential energy over time, which will give you power. And what is changing in the potential energy is mg delta H, which is, if you put it over time, you get power. So what do we get here? We know the mass. The mass is 180. What else do we know? We know G, and we know the height, which is 25. So that is over time. So what is our time? Remember they said per minute. So our time is 1 minute, which is the same as 60 seconds. So when you substitute there, what do we get? We are going to get 180 times 9.8 times 25 over 60. What you get is going to be your power when you substitute in there, when you get after computation. So this is what we get after computation, 735 watts. Okay, let us look at the next question on this very setup. Yes, then comes this question. 8.2, it says the velocity of the intake is still negligible, but at the outlet, water is moving at a speed of 9 meters per second. So what do we do in this case? Okay, we have the same equation. What's the equation? Power is equal to work over time. Remember, work and energy are brothers and sisters, so you can say power is equal to energy over time. Okay, so to answer this question, in this case, you have to know what actually happens. This motor pumps water through this height, so expending what you call gravitational energy or gravitational potential energy. So when water reaches here at this point, let us look at this center A. Water is having velocity 0 horizontally. So then water is pushed and it is ejected at a velocity of 9 meters per second. So altogether, this is what you have to know, that this motor this time around, it's doing two kinds of energy. This motor is doing our gravitational potential energy as we know it, delta EP, but it still is ejecting water at a velocity, so it's creating kinetic energy. So when you divide this one by time, you get the power. So when you expand this one, what do you get? We know that delta EP is mg delta H. And we know delta EK is what? Is a half mv f squared minus a half mvi squared. All of it over delta T will give you power. So what do you have here? It's just substitution. Everything is known. We know the mass of water ejected is 180. We know the height. Height is 25. Then you come to the mass is known, is the same, 180. Then the final velocity is 9 meters per second minus. Remember I told you when water is rising up at this point before ejection, its velocity is 0. So we are going to have a half times 180 times 0 squared. So what you are going to, all of it over what? Delta T. You have to remember that ejection of water is done at is per minute. Whatever work we are talking about here is per minute. So delta T is 1 minute, which is 60 seconds. So our expression becomes 180 times 9.8 times 25 plus a half times 180 times 9 squared, all of it over 60. And what you get will be the answer after computation. So after computation, this is what you get. Our power is 856.5 watts. Okay. Okay, that marks the end of this video. Thanks for subscribing. We thank you for your time. And if you haven't subscribed, please do so. It is to your benefit. Thank you. We meet again. Bye.